So before we dive into working on any engineering design challenges or any projects later on in this class, it's important that we all have a base knowledge of the engineering design process. I mentioned this earlier on in the year, but each teacher and really even each school uses a different engineering design loop. The one I'm going to be going over today is the design loop that every tech and engineering class at the Northern Valley uses. So you learn it once, you may review it year to year, but it's really the same across the board. So it's nice and easy. Our engineering design process here at the high school has 7 steps. Some design processes are larger or smaller, depending, like I said, on the class and on the school. So the first step is to ask, identify the needs and constraints. Then we have researching the problem, developing possible solutions, so that's the third imagine step. Plan, select a promising solution. Create or build a prototype. Test and evaluate the prototype. And then improve or redesign as needed. So the engineering design process is a series of steps that guides engineering teams as they solve problems. So each person within the engineering design team may be responsible for a different step, or they may be going around the design loop together. The design process is iterative, and if you don't know what that means, it means that you repeat the steps as many times as needed, making improvements along the way. So that's why that the engineering design process is kind of formulated in a circle or in a loop, because essentially you can go through the process once and then go through it a second time and maybe even a third time before you get to a final design that's as close to perfect as possible. And making those improvements along the way help you learn from failure and uncover new design possibilities to arrive at even greater solutions than you originally came up with. It also emphasizes open-ended problem solving and encourages engineers, like I said, to learn from failure. Just because something failed once doesn't mean you can go around the loop again and make some more tweaks along the way to improve your design or make it better. So let's dive a little bit deeper into each step. So step 1 is ask, identify the needs and constraints. This is the first step because it helps you identify and define the problem. In this class, I'll be the one giving you a problem to solve, but if you go out into the workforce and become an engineer in the future, you may also need to be identifying problems for others. So things you need to think about are who does this problem affect, what needs need to be accomplished within this design, and what's the overall goal of the project. So even if you just create a list answering some of these questions, it just kind of helps you guide yourself in the design phase along this process. In this step, you also identify criteria and constraints on a project. Like I said, for the most part, I'll be giving you the criteria and constraints. Criteria are just requirement for the solution. Things that, must be within the solution or things that the solution must meet. So, for example, a criteria could be that you're building a paper tower and your paper tower needs to hold a ping pong ball at the top. That's a requirement on the project. That's a requirement for the solution you're trying to create. So that would be a form of criteria. And then constraints are limitations or restrictions on a solution or a design problem that you're trying to find a solution to. So an example of a constraint could be you only get a certain amount of materials. You only get 1 sheet of paper, 6 inches of tape, etc. Or it could also be you're limited on the amount of time you have to design your solution. Just some quick examples of constraints. In step 2, we do some investigation and we also research. So really in this step Sometimes it can take a little while because you want to learn everything you can about the problem. So we later on in the year, like I've been saying this whole time, we're designing catapults. So we're going to spend a good amount of time diving into all the research about catapults, different types of catapults, how they were created in medieval times, why they were created, what they were originally intended to be used for, different things like that. When you are doing research, you only want to use credible sources. Usually you want to stay away from Wikipedia just because, anyone could go on there and edit an article. So you definitely want to stick to credible sources. You can also use this time to investigate products already on the market. So back to my catapults example, you're not the first group of students to be building wooden catapults in school. It's been done for years and years and years. So go to Google, see what other students have created in the past, and that can be a form of research. You can use that to inspire your future designs. And the last part of step 2 is to determine the client's needs and wants. And we talked about different needs and wants earlier on in the year, but you really want to get a gist of what the client, and if you're doing a project for me, the teacher might be your client, but you want to make sure you clearly know what the teacher or the client wants you to accomplish. Step 3 is imagine or develop possible solutions. And in this step, some teachers call this just the brainstorming step because you're spending a good amount of time brainstorming ideas. Your goal is to come up with multiple creative and unique solutions that meet both the criteria and the constraints. Step 4 is plan or select a promising solution. So you want to kind of take a look at your brainstorming ideas. Typically, when we brainstorm in class, we create at least 2 different ideas. Really, I like to push you guys to come up with as many detailed ideas as possible for a solution. But you kind of want to sit with all of those different ideas. Like in this picture, we have plan A, plan B, and plan C, and consider the pros and cons of all the possible solutions. So you might even want to sit there and create like a little pros and cons list that helps you compare and contrast different aspects of your different brainstorming sketches that you came up with. You always want to also keep in mind criteria and constraints of the project when you are going through your brainstorming sketches, because if one of your ideas does not meet one of the criteria outlined in the project brief, you should just automatically X that off right away because you're not going to get full credit. You don't meet all the criteria. And in this step, you also create a detailed sketch of your solution, including dimensions, any materials that you're going to use, any notes on how to put your product together, etc. So in this step, the bulk of the time is spent creating a detailed plan sketch with all the necessary information. The idea here is that you create a detailed enough plan sketch so that you can pass the sketch off to a friend and they would be able to follow your sketch as a blueprint to go ahead and create your product or your solution. Now we have step 5, which is create or build a prototype. This is usually everyone's favorite step. This is where you, like I said, build your prototype of your solution. You can definitely make revisions to your design as you work. A lot of times when I talk about this step, students feel like they need to stick exactly to the plan sketch that they drew out, but sometimes you can't anticipate problems that happen when you are building your prototype. So it's okay to make little tweaks here and there when you are building, and what you come up with in the end doesn't have to identically match what you drew or came up with in your plan sketch. So that's important to note. And just the definition of a prototype is the first working model of your solution. So your prototype is by no means perfect. It just has to work as you intended, so you're able to model the solution you came up with. Then we have step 6, which is test and evaluate the prototype. So you want to put your prototype through a series of tests to see how well it works. Part of this test is to ask yourself and answer, does it meet all criteria? Does it meet all the constraints? Does it meet all my clients' needs? That's super important when you are doing a test. And I have a picture of a balsa wood bridge here breaking when it was under tension from a weight that was hanging on it. In this step, you also talk about what worked during testing and what didn't work. It helps you kind of evaluate your prototype as you're moving forward. And then you also want to communicate your results and get feedback. A lot of times when we're in class, we stop at this stage and we share, our results of testing with each other because sometimes other people may have ideas to make your solution better. And once we do go through the design loop, you'll see you'll have an opportunity to kind of tweak your original prototype and maybe improve upon it in the future. And the last step, which is step 7, improve, redesign as needed. This is where you optimize the solution and redesign parts of your solution that didn't work. So you take a look at your results from testing and you make suggestions for redesign, make some suggestions for improvement. If you were to go through the design loop again. Unfortunately, a lot of times in school, we don't necessarily have a ton of time to go through the design loop 2 or 3, even 4 times. In an ideal world, we would, but still, it always is important to kind of be critical of yourself, take a look at what you've come up with, and see if there's any ways that you can improve upon it. That's, essentially creating an iteration or iterating. Engineers improve their ideas and design many times as they work towards a solution. If you think of the cell phone, for example, even just thinking back, I remember when my neighbor first got the iPhone, it was just called the iPhone. And that iPhone from 10 plus years ago looks completely different than the iPhones that are out today. I have the iPhone 8 Plus and I feel like my phone's outdated. I should have the X or the XS or whatever the latest model is now. So constantly, even if you think of these, huge product corporations, it's almost like every few months they're making improvements on certain products and taking, customer suggestions into play and making products more marketable and just better for everyone that wants them.